Hey there. My name is Zane Peacock,
And my name is Zahra Mohseni.
and we're going to give a presentation on the telecommunications thread here at Georgia Tech and also what it means to us.
Before diving into the slides, I want you to think for a second about the last thing you did on your phone. Maybe you sent a text, checked the news, or listened to a podcast. We do these things so seamlessly that we almost forget the incredible visible infrastructure making it possible. Today, we're going to spend the next 5 minutes talking about exactly that telecommunication. Telecommunication is truly the backbone of modern broadcasting and communication. Whether you're exchanging a tiny bit of data like a quick, I'm running late text, calling a friend, or tuning into a radio, telecommunication is the silent partner helping us stay connected across any distance.
But of course, we didn't start with smartphones. The history of telecommunications is a fascinating journey. It really kicked off back in 1876 with the invention of the telephone. Just imagine how magical that must have felt at the time. From there, the late 1800s brought us radio broadcasting, and the early 1900s introduced television. Nowadays, the whole ecosystem introduces the internet, um, massive cellular networks, and so much more.
So, how does the magic actually happen? No matter how complex a system gets, telecommunication really boils down to three main components. First, you have a transmitter that gets your real information and convert it to electrical signal that can actually travel. Second, you have a transmission medium, which we often just call the channel. Think of this as a road that signal can travel on. And finally, we have a receiver. This catches the traveling signal and translates it back into original information on the other end.
Now, remember that transmission medium or channel that we talked about? The type of medium we use completely defines the type of communication. We essentially have two families. We have wireless communication, which surrounds us right now. Think of your home, Wi Fi, your cellular data, or satellites orbiting the Earth. Then we have wired communication, which is the physical infrastructure, like copper Ethernet cables or the optical fiber cables that run under our oceans. You can see how both wireless and wired systems weave together to create the global web that we rely on.
As you can see here, stations send data through cables or electromagnetic waves. The ones that send or receive data through electromagnetic waves use antennas to catch and through these signals. Sometimes the station will use two entirely separate antennas, a dedicated one just for transmitting out and another one just for the receiving in. But to save space and resources, they can also use exact same antenna to do both jobs, sending and receiving signals, which called transceivers.
Finally, let's look at what actually happens to a piece of data on the journey. Let's say you send a signal. Before it reaches the tower, it goes through a modulator. This packs your data onto a wave that's strong and fast enough to travel. Then it goes through an amplifier to boost its strength before it's broadcasted. It travels through the air to the next tower, where it's caught and sent through another amplifier to restore any energy it lost along the way. Then it's demodulated, unpacked from its traveling wave, so the pure signal can finally reach its destination.
These telecommunication concepts have application in numerous industries. We have highlighted a few here. With a strong telecommunications background, you can work almost anywhere, including AT&T, Verizon, Broadcom, Google, Apple, IBM, and many more.
In our research lab, we work on developing novel telecommunications hardware. We use these exact concepts every day. In order to design low-power, high data rate wireless transceivers, we must understand and implement the communications concepts discussed in this presentation. We constantly search for better ways to send data faster and in a more power-efficient manner. Thanks to these networking protocols and modulation schemes, we're able to push the limits of what is possible with hardware. Thank you for listening.